Question 19. The simultaneous linear equations m minus 2 times x plus 3y equals 6 and 2x plus m minus 3y equals m minus 1 have no solutions for one of these values of m. So writing out the equations first of all. So m minus 2 multiplied by x plus 3y equals 6 and m minus 3, whoops, that's why I need to write them out. So 2x plus, in brackets, m minus 3y equals m minus 1. And no solutions means you're really looking for two lines that are parallel but some distance apart. In other words, parallel and different y-intercepts. And when you have, let's say this was a 2 here, and that was 2x plus 3y equals 6, and the other one is 2x. Now, as soon as this number here becomes a 3, the lines are parallel, because ultimately when you get these in the form y equals mx plus c, you're going to have to divide everything by 3, and you're going to get 2 over 3, and on the other side it's going to be minus 2x on 3, so the gradient of this line will be minus 2/3, and this will also have the same gradient. So same gradients makes the lines parallel, and when the lines or equations are in this form, when you have the same coefficients of x or the same coefficients of y, or if you have something like 4x plus 6y, that's really double this. The ratios of 2 to 4 or 2 on 4, 2 on 4 is equal to a half, and 3 on 6 is equal to a half. So looking at those ratios, if they're equal, then it means the lines are parallel. So in this first step, I'm going to use those ratios to find the values of m that will make the lines parallel. And all you do for that is just go m minus 2 over 2 and let that equal 3 over my m minus 3, and then rearrange until you get m equals something. So cross multiply here, so m minus 2 multiplied by m minus 3 is going to equal 2 times 3, which equals 6. Multiplying that out, m squared minus 5m plus 6, and then minus this 6 from both sides, and you end up with equals 0. So m squared minus 5m equals 0. Factorizing that, you get m minus 5 equals 0. From there, you get m equals 0 or 5. That's a 5. M equals 0 or 5. And so the lines are parallel for either of those two values. Parallel. Okay, now to find out whether or what values of m make the y-intercepts different, all you need to do is pick one of these ratios and let it equal the ratio of these two over here, which ultimately become the y-intercepts of each equation. So it doesn't matter whether you have m minus 2 over 2, I'm going to pick that one. So m minus 2 over 2, I could have chosen 3 over m minus 3, doesn't matter which one, and then let it equal these numbers at the end, or terms that are actually representing numbers for the one that's got a letter in it. Alright, and then again, rearrange this until you find the values of m that make it all right, I'll just rewind a little bit. So when you let them equal each other, you are saying the y-intercepts are the same. So in other words, for these two equations, let's suppose that one was equal to 6 also, you would just be saying 6. The ratio would be 2 over 2 is equal to 6 over 6, so 1 equals 1. And for example, if this was equal to 7, that would be 2 over 2, and then the ratio here would be 6 over 7, and those ratios are not equal, and so you can see that that's going to give you a different y-intercept than this number when you put both of those equations in the form y equals mx plus c. So when you let the ratio of these twos equal the ratio of the numbers here, you are saying that when you're letting them equal each other, you're saying the y-intercepts are equal for whatever values of m make that true. So working that out, so m minus 2 bracket m minus 1, and that's equal to 2 times 6, which is 12. Expanding that out, m squared minus 3m plus 2, and then minus 12 equals 0. So m squared minus 3m minus 10 equals 0. And then in brackets m minus 5, m plus 2 equals 0. And then from there, m equals 5 or minus 2. Therefore, the y-intercepts are equal. Y-intercepts are equal for those two values of m. So what we want is parallel but different y-intercepts. So if the y-intercepts are equal when m equals 5 or minus 2, you want m not equal to those two values, m not equal to 5 or m not equal to minus 2, for y-intercepts to be different, which is what we want. And we also want the lines parallel, and the value of y that makes them parallel, or the common value of that and having different y-intercepts is, well, actually, when m is not equal to 5 or not equal to minus 2, then m can be any other number. In other words, it can equal 0, and 0 is the value that makes the lines parallel. But 5, although 5 makes those lines parallel, it makes the y-intercepts the same, but we want different ones. So that means m equals 0 is going to be the answer that makes them have parallelity. I meant to say makes them parallel, and also different y-intercepts. So different y-intercepts. And that answer is answer E up here, which is the correct answer. So there's a bit of working out to do for these ones, and it's good to practice it because every now and then this kind of question shows up in the short answer first exam. So that's how you do this question, and I'll see you in the next one.